So we spent a couple of days talking about sequences, right? Looking at patterns and things like that. So we also have series. So sequences and series go together. Let me give you the definition of a series. It is the sum of the terms in a sequence. The sum of the terms in a sequence. Sum means you do what with them? Add them, okay? So to me, personally, the word series doesn't sound like it should be a sum. It's like if you have a series of events or a TV series, there's like a bunch of things, right? But you're adding them all up, I guess, to complete the series. So here's some examples of the difference between the two. If I have a sequence that is 2, 4, 6, 8, very simple ones here, that's my sequence. The series then would be the sum of that sequence. So 2 plus 4 is 6, plus 6 is 12, plus 8 is 20. If my sequence is 2, 4, 6, 8, ... What do you think that sum would be? Infinity. What if I had 1/2, 1/4, 1/6, 1/8? It's not infinity. If you think about this, we start with a half, right? And then a fourth is less than a half, so, and then a fourth, or a sixth is less than a fourth. So we keep adding stuff to that 1/2, but we're not adding more than half of the thing before it, right? So this actually ends up being 1. Because the bigger and the bigger the denominator gets, what happens to the fraction itself? It gets bigger, it gets smaller and smaller, so it's going to approach 0, right? The more fractions I get out there, it's going to become closer and closer to 0. So each time I'm adding less and less. So it converges, and if you actually add the infinite amount of them, you get 1. We'll talk more about why later. I'm just going to show you the difference between a sequence and a series right now. So this is if I add them all up. So the sum of, it really maybe should say all of the terms in a sequence. You can leave that out and it means the same thing. Partial sums look like this. You have a sum with an S with a little n there that tells you how many that you are adding up. So this is the sum of a specified number of terms in a sequence. So when you have a sequence, and then it gives you like S sub 7 here, that means you want the first 7. So we can have, that means this S sub 7 will equal to 2 plus 6 plus 10 plus 14 plus 18. Well, that's 1, 2, 3, 4, 5. I need 2 more. What's the next one? 22 plus 26. Okay, so add all those up. See what you get. Calculators on your tape. $98. And, you know, if that was S sub 77, you wouldn't want to have to list them all out, right? So we'll have a way where we can do that without listing them all out. Let's do one more of these. So if A sub n equals n cubed, and I want the sum of those first 5 terms, this is going to be 1 cubed plus 2 cubed plus 3 cubed plus 4 cubed plus 5 cubed. And you don't have to calculate those individually. You can type it in just like that. Obviously, you have the skills of doing it by hand, but Not really the purpose of what we're doing here. Just tell me what the answer is. Okay, any questions about that at this point? You can add things up, right? Yeah. All right, so let's talk about our summation notation. So a different way, so a way to represent a series using the Greek letter, who knows what this Greek letter is? What is it? It's sigma. Last period, everybody seemed to know it, that's why I thought maybe I'll do it for some reason. It's okay if you didn't know it, I don't know why you would at this point necessarily. So summation notation is also just called sigma notation. Looks like that big weird E means you are summing something up. Okay, so you usually have an N equals something at the bottom and a different number at the top. So the number at the top right here, this is the last term number. The bottom is the first term number. And then whatever's to the right of it is the formula for whatever you're trying to actually find the sum of. So this is the formula for this equation. So if I want to find the sum of that series above, I'm going from 1 to 5. So this will be 2 times 1 plus 2 times 2 plus 2 times 3 plus 2 times 4 plus 2 times 5. What do you get? 29. Super close. It's just weird. I don't know how you got off by that much. It's 30.
I was doing
Oh, okay. Oh, okay. But I was like on a calculator. I don't know how you could get off by one. But okay, makes sense. No, I appreciate that. I had somebody last year and I had to wait every time because you go with the crazy ones who's like, have you seen that? Y'all seen that meme where that lady's thinking and all this math is floating around her head, And that's what he does. He sits right there and like I see him thinking, I can just see all this math going around in his head, but he always wants to try and listen. He's usually right. You put on the crazy stuff. Okay. So let's expand these and evaluate. So let's look at number 3. I'm going from the second term to the sixth term. So how many terms do you think I'm going to actually add up? I'm going from 2 to 6. Not going to be 6. 5 move. All right, so let's see what happens here. I'm going to have, this is k squared minus k. So this is going to be, start with the second term. So that'll be 2 squared minus 2 plus 3 squared minus 3 plus 4 squared minus 4 plus 5 squared minus 5 plus 6 squared minus 6. Now, do those parentheses that I wrote in there really have any effect on what's happening? No, it just grouped it because it was like that. I think it makes it look a little nicer that you can figure things out. So when you put it in your calculator, you don't even really need those parentheses. So it's a little easier to type in. So go ahead and let's figure out what the sum is here. What'd you get? 7. Yeah, I can type it in or do it in your head. I'm okay with either way. Or not necessarily even in your head, but scrap. I can like partial in my head and partial I scribble things out so I don't forget what I was thinking. All right, we good? Okay, now look at number 4. Number 4, we have this outside of it. So what we can do is get negative 9/4 and then find this. We're going to find the whole sum and then multiply by negative 9/4. I could multiply by each term, but that would be a way bigger pain in the butt, right? I'm going from 1 to 5. This is going to give me 2 times 1 squared plus 7 plus 2 times 2 squared plus 7 plus 2 times 3 squared plus 7 plus 2 times 4 squared plus 7 plus 2 times 5 squared plus 7. Okay, so you've got two options here. You could type all of that in all at once, okay, which was my big plan the first time I did it. But well, I was thinking I would do it one way, and then I did it that way, and that was a bad mistake. Or I can find the sum, and then once I have that, multiply it by -9/4. The reason I suggest that is because because I'm not but mistakes happen. And so I forgot to put my parentheses there, so when I ended it, then it said I had an error, so then I wished I just found the sum and then multiplied. But either way you do it, go ahead and type that in, or do it on your own, either way. And just know you could be expected to do that without a calculator. You should be capable of that. Not the end of the world, but that's not really the purpose of what we're doing, so I'm not going to make everybody do it. Okay, you want to give me your answer? You want to give me your answer now? Show up? Anybody?
-826.
Why are you giving me a decimal? I disown you.
Oh. -0.0544.
Yes. Oh. And it gives you this first, doesn't it?
Yep.
Yeah, and then you have to turn it into a decimal. Don't do that. Thank you for sharing. All right, we good? Any questions on that? All right. So grab your other sheet of paper. So that was summation notation in general. Let's now talk about arithmetic series. So just like we had arithmetic sequence and geometric sequence, we're going to have an arithmetic series and a geometric series. So today we're just looking at arithmetic. So an arithmetic series is the sum of an arithmetic sequence. And of course, we don't want to have to write out all the terms every time, so we have a formula for that. So the sum, this says the sum of an arithmetic series. It really should say the sum of an arithmetic sequence or an arithmetic series is 1 to 2, but that's poorly worded, my fault. We'll just ignore that for right now, but the sum of however many terms I'm doing, n equals n times a1 plus an over 2. Where n is the number of terms, a sub 1 is the first term, just like it has been, and a sub n is the last term. All right. Let's think about what we need. So it says find the indicated sum for each arithmetic series. So I need the sum of first 18, but I don't want to have to write them out. I want to use this. So the things I have to know is I have to know n. What's n? 18. I have to know the first term. That's 7. I have to know the 18th term. Do I know the 18th term? No. Do I want to have to write them all out? No, because it could be the 88th term. You definitely don't want to have to do that. So how do we find a specific term in a sequence? Do we know how to do that? Did we do that on Monday? Yes, we did. We did the a sub n is equal to the common difference times n minus 1 plus the first term. Okay. So the 18th term here is going to be the common difference. So what's the common difference in this sequence? 3. Do 3 times 18 minus 1 plus the first term, which is 7. So then that gives me that my 18th term is 58. So now that I have that, I have n, I have the first term, I have the last term. Now I can do my sum. The sum of those 18 terms is n, which is 18, times the first term, which is 7, plus the last term, which is 58, over 2. What should we get here? Okay. Any questions about that? All right. Let's look at number 2. What is n? 35. First term is 50. The 35th term is going to be equal to, what's the common difference? -8 times n, which is 35, minus 1, plus the first term, which is 50. When you get that, you'll get -222. Hopefully. So we got n, we got the first term, we got the last term. You go ahead and find the sum of the first 35 terms. -3010. Any questions about that? So this subscript on the S doesn't always necessarily mean the first 18 terms. If you're given a sequence, that is, because that's the only information that you have. But when we're given the summation notation, it's going to be just however many terms we're actually finding. It's whatever n is. So we're going to skip number 3. We're going to look at number 4. Okay? And we're going to sum up these terms here. So before I do that, I still need the same information. I need n, I need the first term, and I need the last term. So what do you think n is here? I'm going from 4 to 17. Well, it's not 7. I'm not going to have 17 because I'm not starting with 1. I'm starting with 4. Does 13 sound good? All right, count them on your fingers. Start with 4. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. It's actually 14, right? So it's not just the top minus the bottom, because that would give me 13 when it's actually 14 when you count it out. Okay, so there's 14 here. So when I do 17 minus 4, I get 13. What do you think I can do with that to get 14? How do you get from 13 to 14? Add 1, right? Is that easy? So the way you find n every time, it is the last number minus the first number plus 1. So it's 17 minus 4 plus 1. That's where we get n equals 14. All right, so then I need the first term. They didn't give it to me this time, but my first term isn't actually a1. My first term is the fourth term. So when I find that, that's going to give me 5 times 4 minus 27. And that will be what? -7. Okay. Then I need the 17th term. Right? And that's going to be 5 times 17 minus 27, which gives me 58. So notice 14 isn't one of these. It's the 4 and the 17 come from there. So now that I have all of that, I can find the sum. The sum of 14 of those terms is n, which is 14, times the first term, which is -7, plus the last term, which is 58, over 2. What do you get? Okay? Any questions? All right, so let's look at number 5. What would n be here? 30 what? 6. You don't want to have to draw your fingers at that, right? So 36. It's 38 minus 3 plus 1. I need the first term, which is actually term number 3. That'll give me -8 minus 3/2 times 3. What is that? -25 over 2. I don't know how I get the other stuff there. -25 over 2. Then I need the 38th term. That's going to be equal to -8 minus 3/2 times 38. Now on that calculator, if you just arrow to the left, they'll let you put an 8 right after that 3. You don't have to do anything else. What do you get there? All right, so I have all the pieces that I need. You go ahead and find the sum of those 36 terms. All right, anybody willing to give me a number? No. Yes, -1395. So double check what you typed in. See if you- Oh, it's -25. There we go. All right, any questions? Yes.
33.
Sorry, what?
What's 33?
You do, that's where you find n like this. 38 minus 3 is 35, and you add 1, you get 36. Anything else? All right. Let's look at some applications. So Michaela is training for a marathon. She ran 2.4 miles the first day, 2.55 miles the second day, 2.7 miles the third day. If this pattern continues, find the total distance she ran after 60 days. Okay? So we still need to say we're going to add up all her time, all her distances, but we're going to use the same kind of information. We need n. What do you think n is here? 60. How many days we're adding up, right? What is our first term? 2.4. Our last term would be the 60th term. So we need the common difference for that. What's the common difference? 0.15. If I take 2.55 and subtract 2.4, I'll get 0.15. That'll be times 60 minus 1 plus 2.4. 11.25. And in this case, a decimal would be fine because everything's in decimals. Okay. So now that we have that, we can do the sum of those 60 days. That's going to be 60 times times 2.4 plus 11.25 divided by 2. We're on 9.5. But with application problems, you have to get used to actually explaining what your answer is to show that you know what the heck you even found. So what we could say here is, after 60 days, she could run 409.5 miles. And your words wouldn't have to be exactly like this, but you pretty much have to say that in whatever words come out of it. Any questions about that? Okay. So let's look at the next one. Got tickets for a concert opened up for sale online. The number of people that purchased tickets in each of the first 4 minutes is shown in the table to the left. If this pattern continues and the concert venue can hold a maximum of 75,000 people, find the number of tickets left after the first 2 hours. Okay, so if I want to know the number of tickets left after the first 2 hours, I have to figure out how many tickets were sold in the first 2 hours, right? Because that's the information that I have. So what do you think N would be? 120, because this is in hours and this is in minutes, right? So N is 120. In the first minute, they sold 35 tickets. So the first term, 35. I need the 120th term, which means I need the common difference, which is 8. So I'm going to have 8 times 120 minus 1 plus 35. We should get 987. Very good. All right. So now I'm going to find the sum of the, how many tickets were sold in the first 120 minutes. So I have N, which is 120 times 35 plus 987 divided by 2. So that sum is equal to 1. So is that the number I'm looking for my final answer? No, because that's how many tickets were sold. We want the number of tickets left. So what do I have to do with this number? Subtract it from what? 75,000. So there should be 75,000 tickets available. I subtract that 61,320. That gives me 13,680. Then I can say that after the first 2 hours, there were 13,680. Any questions at all? Good? Awesome. So your assignment is in Delta Math. Make good use of that time and be ready for your quiz tomorrow.